Hi, I'm Dr. Neenu Garg. In this session, I will discuss first come, first serve scheduling algorithm. Let's start. FCFS stands for first come, first serve. This algorithm says that the process that requests the CPU first is allocated the CPU first. Or we can say the process which has the least arrival time is scheduled first. Means if there are two processes P1 and P2, P1 arrives at time 0 and P2 arrives at time 1, then P1 will be allocated to CPU first, and then it will keep the CPU until P1 terminates, it completes its execution, or it leaves the CPU for input output. After that, P2 will be scheduled. It is a non-preemptive scheduling algorithm. It means if some process is executing in CPU and any other process comes in ready queue, if this process has high priority than P1, even then CPU will keep executing process P1 because FCFS is a non-preemptive algorithm. It is not a priority-based scheduling algorithm. Yes, processes are executed on the basis of their arrival times. The process which has least arrival time is scheduled first. There is no priority on the basis of which a process is allocated to CPU. And it is very simple form of a CPU scheduling algorithm. It is very easy to code and implement. The problem with first come first serve is the average waiting time. If a large process arrives first, then this large process will keep the hold of CPU, and the processes which have small CPU bursts will have more waiting time. Okay, so it greatly impacts the average waiting time. Average waiting time increase if CPU is with some process which has large CPU burst. Okay, let's understand FCFS with the help of an example. There are 5 processes P1, P2, P3, P4 and P5 in main memory, and these 5 processes are in ready state. P1 came into main memory at time 0, P2 came at 1, P3 came at 2, P4 came at 3 and P5 came at 4. So these are the arrival times, and these are the CPU burst times. Means process P1 needs 4 milliseconds of CPU, P2 needs 3 milliseconds of CPU for its execution, and so on. Okay, so we'll understand this problem by plotting a Gantt chart. So this is a Gantt chart. We started with time 0. Now at time 0, scheduler do not have any choice. There is just one process, P1. So P1 will execute in CPU. P1 will keep the CPU till time unit 4. Okay, because its burst time is 4. So P1 is done. Now at time 1, 2, and 3, P2, P3 and P4 came in main memory and are in ready state. But P2 is first among P2, P3 and P4 to come in main memory. So CPU will be allocated to P2. So after 4 time units, P2 will execute, and it will execute for 3 time units. So it will execute till 7 time units because its burst time is, as you can see, it's 3. 4 plus 3 is 5. So P2 is done. At time 4, there are 3 more processes in main memory. Okay. but the arrival time of P3 is earlier than P4 and P5. So after P2, P3 will take hold of CPU. So it will execute till 8 because its burst time is just 1 unit. After that, arrival time of P4 is earlier than P5. So it will get hold of CPU. Scheduler will give P4 to CPU and its burst time is 2 units. So it will execute till 10 time units. P3 is done, P4 is done. Now there is last process which is left, which is P5. It will execute and the burst time is 5. So it will execute till 15. Okay. This chart is known as Gantt chart. So it is recommended that you plot a Gantt chart for such type of problems. These will help you to calculate turnaround times, waiting times, response time, and completion time. Now let's find out the completion time. Completion time is a point in time. See the Gantt chart carefully. If we want to find the completion time of P1, completion time of P1 is 4. Completion time of P2 is 7. P3, 8. P4, as you can see, P4 completes at 10. P5 completes at 15. See, these are the completion times of P1, P2, P3, P4 and P5. If you have any doubts about what is completion time, turnaround time, waiting time, response time, I would recommend you to see the video of various times of a process. Before watching this scheduling algorithm video, please refer to this video. Now let's come to turnaround time. We all know that turnaround time, it's a short form I'm writing. Turnaround time is the time when a process arrives in main memory to the time it leaves the CPU. So it is basically completion time minus arrival time. So if I talk about process P1, completion time of process P1 is 4 minus its arrival time. It is 0. So its turnaround time comes out to be 4. 4. For P2, completion time is 7 and arrival time is, as you can see, it's 1. 7 minus 1, that gives you 6. For P3, similarly, completion time is 8, arrival time is 2. It gives you completion time, turnaround time 6. For P4, completion time is 10, arrival time is 3. That gives you turnaround time as 7. And last, for P5, completion time is 15, arrival time is 4. So that gives me turnaround time of 11. From here, I can also compute average turnaround time. You just simply add all these, that is 4 plus 6 plus 6 plus 7 plus 11. The number of processes is 4. So we'll divide it by 4. Let it comes out to be X. So this X is the average turnaround time. I am leaving it to you. You can compute it easily. Okay. Next come to waiting time. Waiting time, I would like to remind you that for scheduling algorithms, we consider that waiting time of a process for IO is negligible. So we consider the waiting time here, the time which is spent by a process in ready queue, waiting for CPU, okay? Not for IO. This waiting time is the time which a process is pending in a ready state. It was in ready state, okay? So waiting time is basically, if we just subtract the CPU burst time from the turnaround time, if we subtract the time a process spent with CPU from the total time the process remains in the system, that will gives us the waiting time. So let's compute it for P1. Turnaround time of P1 is 4 and burst time is 4. So waiting time is 0, which is also very true, as you can verify it from Gantt chart. The arrival time of process P1 was 0, and as soon as it arrived, it was allocated to CPU. It did not wait in ready queue. So its waiting time is obviously 0. For P2, the turnaround time is 6. However, the process arrived at 1. So it waited for CPU for, sorry, I have to subtract its burst time. Again, I'm repeating, the turnaround time of process P2 is 6 and the total time it spent with CPU is 3. So subtracting it, I'll get 3 units. So it means process P2 waits for a CPU for 3 time units, which is also visible. Process P2 came in the system at 1 time unit and it was allocated CPU at this. So you just compute 1, 2, 3. So waiting time is 3 time units. You can verify your computations with Gantt chart as well. For P3, turnaround time is 6 and CPU burst time is 1. That gives me a waiting time of 5. Okay. For P4, turnaround time is 7 and CPU burst time is 2. That gives waiting time of 5. Okay. Oh, yes, 5. And for P5, turnaround time is 11 and burst time is 5. So waiting time comes out to be 6. Please ignore if there is any computation error, you can ignore. You can calculate on your own by using these formulas. Okay. So these are the turnaround times and individual turnaround times, and these are the individual waiting times. From here, you can calculate the average waiting time. Average waiting time will be sum of waiting times of all the processes in the system divided by the total number of processes. In this case, it is 5. So you can calculate this value. I am leaving it for you as an activity. You can compute this value, average waiting time. Now next come to response time. It is important to note that response time in case of a non-preemptive scheduling algorithm is same as waiting time. Please note, write down this point if you're making any notes. Response time in case of a non-preemptive scheduling algorithm is same as waiting time. So what we will do, we will just copy the waiting times in the box of response time. So this was all about different times in case of first come, first serve algorithm. There is a small activity for you. You have to complete both the tables and you have to use first come first serve scheduling algorithm for this. Refer to the previous slide, previous computations that I have done, and use the same type of same type of formulas to fill this table. And then what you have to do is you have to find the average waiting time in each case. You can also find average turnaround time. What you have to do is you have to notice the change in average waiting time on changing the order of arrival of processes. In this case, P1 is a long CPU burst process, or I can say it is a CPU bound process. So it will keep the CPU for 24 milliseconds. P2 and P3 holds the CPU just for 3 milliseconds. These two processes have short CPU burst. So you have to find out the average waiting time in this case. The case when a CPU bound process came first. Second is the case when the process with short CPU burst get the CPU first because they arrive early. Okay. And the process with long CPU burst arrive late, so it gets the CPU late. So in this case, you also have to find the average waiting time. You just notice the change in the average waiting time if the long CPU burst process arrives late. So just notice the change. For your information, average waiting time will reduce. In this case, average waiting time will reduce. By letting shorter CPU burst process to execute first, one can reduce the average waiting time. But I want that you solve both these cases and then observe the results on your own. So this was all about first come, first serve scheduling algorithm. I hope you understand the session. Thank you.